Hello again, everyone. Yesterday, in our last lesson, we learned about what causes the day and night cycle. I'm going to pretend that I am the sun, and this is our Earth. On our Earth, we live in North America, about right here. When the part of the Earth that we live on is facing towards me, it is daytime. But remember, the Earth has an invisible line through the middle called its axis. The Earth rotates or spins on its axis. When the part of the Earth that we live on is facing away from me or away from the sun, it is nighttime. Today we are going to learn about another cycle in nature. We're going to learn about the cycle of the seasons. Remember, a cycle is a pattern that repeats over and over again or moves in a circle. The cycle of the seasons is spring, summer, fall, and winter, and then it moves back to spring, summer, fall, and winter again and again each year. In Utah, sometimes our springs and our falls are not very long seasons, but we do have all 4 seasons. In different parts of the world, seasons look a little bit different. Today we are going to talk about seasons in the northern hemisphere. When I say hemisphere, I'm talking about a specific part of our world. Our world is split in half by an invisible line that we call the equator. Halfway around the planet is what we call the equator. It's an invisible line just like the axis. The upper part of the equator, or the northern part that's up above, is the northern hemisphere. The lower part, or the one that's facing downwards or south, is the southern hemisphere. Where we live in the United States of America, in North America, is in the northern hemisphere. So that's the cycle of seasons that we are going to be talking about today, the ones that exist in the northern hemisphere. Again, we talked about how the Earth moves on its axis, or rotates on its axis, but the Earth moves in another way as well. Not only does it rotate, it revolves. While it is spinning on its axis, the Earth rotates or moves around the sun in a circle. So it is spinning on its axis and moving around the sun in a circle at the same time. We'll talk about how the rotation of the Earth causes the change in seasons. Or revolution, sorry. The rotation of the Earth causes day and night, the rotation on its axis, but the revolution, or its movement around the sun, causes the seasons. Before we learn about that, though, we need to go over our vocabulary words.
Revolves. Revolves means it moves in a circular path around an object. The Earth revolves around the sun once every year. Equator. The equator is an imaginary line that divides Earth into the northern and southern hemispheres. People who live near the equator experience mild seasons and live in warm climates. Hemisphere. A hemisphere is half of the Earth as divided north and south by the equator, or east and west by the prime meridian. We live in the northern hemisphere because we are north of the equator. Tilt means to slant or place at an angle. Andrea will have to tilt her water bucket so that every drop can spill out onto her plants. I want you to tilt your head. So you're going to turn your head to the left and then tilt it to the right. Remember, tilting means that we are putting our head at an angle or slant. Right now, Earth is moving. Even though you cannot feel it, Earth is always moving in space in two different ways. The first way the Earth moves is called rotation. Rotation is the movement of Earth around its axis. This controls the cycle of daytime and nighttime. The Earth takes 24 hours to turn or rotate once on its axis. The Earth rotates in a counterclockwise direction from daytime to nighttime and back to daytime again. Counterclockwise means to move in the opposite direction that the hands on a clock move. During rotation, the part of Earth that is facing the sun changes. When it is daytime where you are, that means that the part of the Earth on which you are standing is facing the sun. Sunlight hits our planet and moves across it from east to west. This is why we see the sun rising in the east and setting in the west. Sunset eventually occurs when certain parts of Earth turn or rotate away from the sun and nighttime begins. This cycle continues over and over again. The second way the Earth moves is called revolution. Earth revolves or orbits around the sun in an almost circular path. Therefore, as you live on Earth, you are traveling around the sun too. It takes Earth 365 1/4 days, or 1 year, to complete one revolution or orbit. You might be wondering about the 1/4 of a day. This 1/4 explains why we have a leap year every 4 years. 4 quarters equal 1 whole, or 1 whole number, just like 4 quarters equal $1. During a leap year, we add on 1 additional day to the calendar to catch it up to Earth's orbit around the sun. We add 1 day in February, February 29th, every 4 years. Earth is tilted as it orbits the sun. Tilt, or slant, your head to one side. The Earth remains at this same angle and points in the same direction throughout its entire orbit. Now let's find out more about how Earth's tilt causes the seasonal cycle. Earth is divided into hemispheres, or halves. Just like an orange can be cut in half either through the center from the side or from the top to the bottom. Earth can also be divided in 2 different ways. Our planet is divided in half into the northern and southern hemispheres by an imaginary line on its surface called the equator. The equator is the same distance from the North Pole as it is from the South Pole. The United States, where we live, is located in the northern hemisphere. Earth can also be divided into 2 halves called the eastern and western hemispheres. These hemispheres are divided by the prime meridian, an imaginary line used to split the Earth into eastern and western halves. When the northern hemisphere is tilted toward the sun during Earth's revolution around the sun, it receives more intense light from the sun at a more direct angle. During this time, it is summer in the northern hemisphere. Around June 21st each year, the sun reaches its highest point overhead in the northern hemisphere. This is called the summer solstice and is referred to as the longest day of the year. That means that there is daylight for a longer period of time on that day than on any other day of the year. People in the southern hemisphere are experiencing winter, while people in the northern hemisphere are experiencing summer. On June 21st in the southern hemisphere, that part of Earth is tilted away from the sun, with the sun at a low angle in the sky. The sunlight is not as strong or as intense, and there is less of it, so that part of Earth receives less light and less energy than the northern hemisphere. June 21st is the winter solstice, or shortest day of the year in the southern hemisphere. It is the opposite of the northern hemisphere. North and south are opposites. They are opposite directions. As Earth revolves around the sun, the seasons begin to change, depending on which hemisphere is tilted most directly toward the sun. This depends on where Earth is on its revolution or orbit around the sun. One revolution takes 1 year, and each hemisphere is tilted directly in the sun for part of the year. 6 months after the longest day in the northern hemisphere, the shortest day occurs. The winter solstice in the northern hemisphere is on December 21st. This is, of course, the longest day of the year, or summer solstice, in the southern hemisphere. They are opposites. When Earth is halfway between the two solstices, both hemispheres receive the same amount of sunlight. This means that the hours of daylight and darkness are the same in each hemisphere. The days that are equal are called equinoxes. The spring equinox occurs at the beginning of spring on March 21st. The autumn equinox occurs at the beginning of autumn on September 21st. The cycle of one complete orbit or revolution of Earth around the sun marks or measures 1 year. Living things respond to the changes in sunlight and warmth throughout the 4 seasons of the year. With increased sunlight and warmth during spring and summer, many living things tend to grow well. Animals are born and plants grow. With decreased sunlight during autumn and winter, some plants are ready to be harvested, whereas others die. Some become dormant or stop growing and making new leaves for the winter, and wait for the sunlight to return. You will see that most trees do this in the fall and winter. Some animals, to avoid the winter chill, hibernate or migrate. When animals migrate, they move to warmer environments. Not every part of Earth experiences 4 different seasons. Different areas of Earth have different types of weather. This is partly because of the shape and tilt of our planet. This means that different parts of Earth receive different amounts of sunlight and warmth. The area around the equator receives the greatest amount of direct, intense sunlight. So some of the warmest parts of Earth are located in that part of the planet. The North and South poles are at opposite ends of our planet, and they receive the least direct sunlight. In fact, although they are so far apart, they have the same kind of weather as each other. It is always cold in the North and South poles, and both places are usually covered with ice. In the next lesson, you will learn more about the cycle involving the 4 seasons and how each season brings with it an ever-changing landscape. Which season is your favorite?
All right, my friends, I have got some questions for you about what we just read. First, I want to know, how long does it take the Earth to orbit around the sun once, or to revolve around the sun once? How long does it take? You've got it. It takes a year or 365 days. Ooh, how long does it take to complete one rotation? One rotation is just 1 day or 24 hours. We talked about how the Earth is split by an invisible line called the equator into 2 hemispheres. Which hemisphere do we live on? Do we live on the northern hemisphere or the southern hemisphere? We live in the northern hemisphere. The first day of summer is called the summer solstice. What is special about that particular day? about the first day of summer? The summer solstice, or the first day of summer, is the longest day of the year. We have more hours with the daylight on that day than any other day of the year. The first day of winter is called the winter solstice. What's special about that day? You've got it. That day is the opposite. On the winter solstice, we have the least amount of daylight, the least hours of daylight than any other day in the year. It is the shortest day of the year. What do both the first day of spring and the first day of autumn have in common? I'll set my globe down. The first day of spring and the first day of autumn, what do they have in common? Those days are special. We even have a special name for them called equinox. On an equinox, there is the same amount of hours of daylight and darkness. How are plants and animals affected by the seasonal cycle? Right. In the summer, when there's more sunshine, plants tend to thrive. But in winter, when it's cold and dark, they don't survive as well. Many animals will also hibernate during the winter, like bears, because the cold is too extreme for them. Other animals will move for the winter. Many birds migrate or fly away to warmer places during winter in the northern hemisphere. All right, my friends, I'm going to get my globe and I'm going to grab a flashlight to use as my sun, and we'll talk a little bit about both the day and night cycle and the seasonal cycle. Remember, the day and night cycle is caused by the Earth's rotation around its axis. Our axis is shown on this globe by these gold poles that stick out of the top and bottom of the globe. The part of the Earth that is facing our sun, our flashlight here is our sun, the part of the Earth that is facing the sun experiences daytime. But as it rotates, that same part of the Earth is now facing away from the sun and is experiencing nighttime, and the opposite end is now experiencing daytime. The seasons, or the cycle of the seasons, is not caused by Earth's rotation on its axis, but by Earth's revolution around the sun. And we'll see what that looks like. All right, my friends, we have got our bright yellow sun right here. We are going to talk about the Earth's revolution around the sun. So not its rotation around its axis, but its revolution around the sun. We're going to start right here. Notice that our axis is pointing this direction. It is pointing away from the sun. You'll also notice that our northern hemisphere, so our Earth doesn't lay flat. Remember, it's at a tilt on the axis. So our northern hemisphere is tilted away from the sun. In this position, when the Earth is in this position near the sun, we get less direct sunlight, which means that our days are longer and temperatures are colder. When the Earth is in this position, with the northern pole pointed away from the sun, it is winter. As the sun moves, it comes behind the sun. I'm going to hold it up a little bit so we can see that position. In this position, it's no longer facing directly away from the sun, but it's not full on facing the sun either. In this position, it is spring. In springtime, our days get a little bit longer and our temperatures warm up a little bit as well. As we continue moving, we come to this position. Ooh, I almost knocked our sun over. In this position, our North Pole is pointed towards the sun, and the northern hemisphere is also tilted towards the sun. Because it is tilted towards the sun, we have longer days and hotter temperatures. This shows the season summer. And lastly, when we come in front of the sun, again, we're no longer fully facing the sun or are tilted towards the sun, but we're not fully facing away from the sun. This season is fall. Remember, our Earth is constantly making this revolution around the sun, while at the same time rotating on its axis. It is both making revolutions and rotations. All right, my friends, I'm going to have you pull up the PDF that's attached to this assignment, and we'll go through it together.
All right, my friends, when you get that assignment opened up, it is going to be sideways. So that's our first thing we need to fix. Go ahead to this hamburger right here, these 3 lines that are stacked on top of each other. Click on it, and we're going to rotate clockwise. Now we've got it facing the right direction. All right, we have a diagram on this page of the Earth's position around the sun. We know here is northern spring, and here is northern fall. We have to decide where winter and summer go. Take a minute to look at the Earth's position around the sun. Think back to my example where I showed you where I moved the globe around my sun. In this picture, we've got our axis, which is always facing the same direction. It will always be pointing towards the right. Our axis is pointing towards the sun, and the northern hemisphere, we can see this line, our equator, that is splitting our Earth into the southern and northern hemispheres. We have a stick figure here to show that we are in the northern hemisphere. Our northern hemisphere is tilting towards the sun, and we have longer days. What season is that? Is that summer or winter when we are facing towards the sun and have longer days? Go ahead and write that season on this line. Let's look at our second one. In our second one, our axis is pointed away from the sun, and our northern hemisphere, where we live, is tilted away from the sun. Because we're tilted away from the sun, when the Earth is in this position, we have shorter days. What season is that when we are tilted away from the sun and have shorter days? Is that summer or winter? Go ahead and write that season on number 2. When you are done with this one, go ahead and turn it in. We've got one more thing we're going to do today, and then you will be finished with knowledge.